These two are actually equal, but one of them is not allowed. This one, you're not allowed to have a square root in the denominator. In algebra, you may be taught something called rationalizing the denominator, and that's what I want to teach you today. Here we have a square root of a fraction. We're going to take the square root of the top and the square root of the bottom because that's how you do the square root of fractions. And then you simplify anything that you can. And we can simplify the top because the square root of 1 is 1. We cannot take the square root of 3 and get an integer answer. It would just be this big long decimal. So what we do instead is we do something called rationalize. We take the square root of 3 times itself. If you do something on the bottom of a fraction, you have to do the exact same thing on the top of the fraction because, you know, that you want to keep them equal. So what we have now is 1 times the square root of 3 over, when you multiply two square roots together, you just multiply the numbers inside underneath one square root sign. So that would be 3 times 3. And then you end up with the square root of 3 over 3 times 3 is 9. Do you see the evil plan yet? You see what's going to happen right here? Well, the square root of 9 is 3. So the square root of 1/3, when simplified, equals the square root of 3 over 3. And yeah, simplified is a math term. You probably don't think that seems very simple. Okay. So here's how we do it in real life. Usually, we don't write out these steps. This is kind of done in our heads. When you're rationalizing a denominator, if you take the square root of a number times itself, the square root signs just pretty much cancel. You end up with just the number itself. So that's how I'm going to do it from now on, unless I think it's a little complicated, and then I'll write out these other steps. So let's try it again. Only this time, let's make it a little bit more realistic for your Algebra 1 class. We're going to take the square root of 2x over 7. Well, you start out by taking the square root of the top over the square root of the bottom. Now we're going to rationalize that denominator by taking the top and the bottom times what we see down here. At least for this problem. There's other techniques for rationalizing, but today we're keeping it pretty simple. Square root of 7 times the square root of 7. We have the square root of 2x times 7. Remember, 2x times 7, that goes on the inside of one square root sign. And on the bottom, we have one square root sign, and we're going to do 7 times 7. 2 times 7 is 14, so 2x times 7 is 14x. And we have the square root of 49 because that's what 7 times 7 is. But 49 is a perfect square. It's 7 squared. So it's going to turn out exactly how you think it's going to turn out. Boom. Square root of 14x over 7. Now stop here. Be very, very careful. There are going to be people who are going to want to keep going because they see 14 as 2 times 7. But this is not really the whole number 14. This is the square root of 14 times the square root of x all combined. So be super careful here. Don't go any further. This is the final answer. You are done. There's a lot of stuff going on with this problem, but we start out the same way. If you're not sure how to start, you're going to take the square root of the top, the square root of the bottom. I'm going to rationalize. So I'm going to take the square root of 5 times the top and the bottom. And what I'm going to get here is a square root of 12 times 5 times x cubed. So that'll be 60x cubed over 5. Square root of 5 times the square root of 5 just turns out to be a 5. Now you might think you're done, but you need to check and see if there's anything in here you can pull out. I mean, right away, I see x to the 3rd power, and I have it underneath a square root sign, so it means something needs to come out. So I need more room. Let's see if we can simplify this a little bit. If you're not sure how to simplify square roots, I'll put a link here so you can go and look at that video, which is kind of just a basic introduction to what I'm about to do. I broke 60 down, and it has factors. I could have used 2 times 30, but neither 2 or 30 are perfect squares. There's more than one way you could have broken that down. I was just going for a perfect square, and I ended up with 4 times 15. 4 is a perfect square, 15 is not. Then this x cubed, I rewrote that as x squared times x. Again, I'm looking for perfect squares if I'm taking square roots. And then the 5 just came along for the ride. So what we have now is I decomposed all this. Instead of having it all be together in one square root, I broke it up into 3. The square root of 4 times the square root of x squared, because those two are perfect squares, so they got their own. And then the leftovers, 15 and x, stayed inside their own square root sign. These two can be simplified. So we end up with the square root of 4, which is 2, the square root of x squared, which is just x, and that is 15x that stays inside all over 5. And that is your final answer. Thank you so much for watching, and I will see you next time. Bye!